Now, anybody in this situation with a flat architecture like this could connect packet sniffers and see broadcasts for all of your traffic. They could sabotage your working ports because they can plainly see what traffic is coming from which ports. They could invoke denial of service attacks based on this. They can perform ARP, or address resolution protocol spoofing. They can copy and send back responses based upon data they've gleaned just by sniffing the network. And they now know what IP and port is sending exactly what kind of data packet, so your network is compromised. It's open to what's known as man-in-the-middle attacks. So if one of your employees just happens to, say, activate and deploy, accidentally of course, a rootkit on their machine, say they open an email of questionable content, there's an attachment, and they run the executable. That rootkit now obtains your default and automatic login information for an application server. And now some bored hacker kid has the IP address and username and passwords of at least one user and the servers he or she logs into. It's all recorded and emailed to them right through your own firewall because the user who activated the virus has rights on your network. And perhaps you've only some basic software security installed on your network because maybe you've set it up yourself. Maybe you're not a tech guy. So you don't really have truly enterprise level email server solutions installed. A virus attack is just a very real possibility in a network like this. It happens all the time. I get service calls regularly. I can't tell you the number of times where I've gone into small offices and every machine has some form of malware on it. They've got a network, yeah, only in the loosest definition of the word. A large number of hacker exploits and attacks are geared exactly to this small business type of environment because the hackers know you've got poor equipment and little or no standards controlling anything software or hardware-wise. So it's an interesting exercise for these hacker people to flex their muscles on a small business, just to see what they can do, if they can do it. And generic lower-level switches and routers are usually very attackable. Their MAC address tables can be filled easily, just using a couple of programs that are available to anybody who's got access to the web. And now, after the MAC tables are flooded full, you'll get all the data sent to anybody on the network because you'll essentially reduce these switches to a bunch of hubs. The network will crash easily under these conditions. These are issues associated with MAC flooding. And what this means is, yes, switches do dynamically learn MAC addresses, but thankfully, by the way, Microsoft has gotten better at their operating system design. Their machines aren't quite so uselessly noisy, broadcasting so much garbage themselves anymore. Windows XP and 7 actually can be very quiet on a network now, so it is so much that way that if there is very little or no network activity for 5 minutes, and with Cisco the default is 5 minutes, a switch will age out or forget the MAC address of the device. If it's quiet long enough, it'll disappear from the MAC table. So the converse of the flooding situation is that the switch must relearn the addresses the next time there is any network activity. And this is okay, this is how switches are supposed to work, but the larger and larger this domain gets, and you start attaching all these different devices, you do then have issues again with switches forgetting the MAC addresses. It isn't really a major problem, but the next time that a switch is asked to access that particular device, it then has to broadcast the request everywhere looking for the device. But the more devices you have attached, the more addresses that get forgotten, and ARP has work to do now. And this can become quite bad actually, especially in smaller businesses. Just to give you an example, I've seen small businesses that barely had 2 or 3 employees, and yet they had quite a few machines, like 10 or 15 machines, say, up and going at a time. These machines are usually up and running, but relatively idle. But they're up and running. And when an application has to function, there could be lag. At that particular moment of the request, at that moment of demand, the network is not too efficient or responsive. At the moment of immediate demand, a service may choke because it's looking for an immediate response. If and when a device is found, now that device may have to awaken, then respond. And in the meantime, there is significant lag. And these people will wonder why they have difficulty. That's because the network configuration is not optimized, and cheap equipment may not help either. So, this finally brings us to the Enterprise Composite Network Model, or ECN. This is Cisco's core campus design. And when I say campus, I mean all one network attached together in one location. It could be a multi-department business under one roof, or one geographically close yet spread out location between several different buildings. This is what they recommend as a design for every network. You'll find a lot of documentation on this standardized approach. It's all good stuff, but let me boil it down to fundamental big picture like this. Oh, and just take note of one thing immediately here with these diagrams. Let's go back and forth here a little bit. See this and compare this. This versus this. You see the redundancy here with the lines at the access level and between different layers? This is set up with minimal redundancy built into it. Loss of one box or one line will not entirely cripple the business, and that's the whole idea. It's why there is a price tag associated with this. It's not just a bunch of boxes plugged together haphazardly by an office manager with some freeware installed on it. Now, I'm not saying a decent do-it-yourself job can't be done. It's just that usually offices have built-in vulnerabilities, and this versus this. This is the first step to an enterprise solution. Now, in the enterprise composite model, all that Cisco is after, ultimately, from you designing a network, is that you design your networks in blocks, meaning you create these network architectural elements that are separate from each other, and all of them are manageable. First of all, you have to go back and think about Cisco's three-tier model. You have an access layer, the distribution layer, and the core layer. The access layer is where devices connect to the network. For example, one block may serve as access for the server farm in a small enterprise. So these servers can work as a group, they can access their data, communicate amongst each other, replicate, and all that cool stuff they need to do, all inside their little block. But if they ever wanted to get off that network, that's where the distribution layer comes in. That's typically where the packets shuffle around and spend a little time getting sorted out. The first thing that happens is routing, usually. You're typically routing these packets because they're trying to leave their local network and access either the internet or perhaps one of the other switch blocks that you've designed. That's typically where you have access list checks to make sure that this server or this device or this user, whatever, is allowed to access the requested resource. This is where you kick in your quality of service analytical routines. And this usually is where a lot of the actual network work is going on. It's where the gears of network administration turn and make things happen or stop happening. Now, that distribution layer will typically forward up to a core layer. Now let me first off mention, most companies, unless you are very, very large, do not truly have a core layer. A lot of them will use what's referred to as a collapsed core layer, which means the distribution and core are one layer. And that's typically where you have, say, a couple of buildings. They all have an access layer. I say building, but it could be departments, all under one roof. And all these departments share the distribution / core layer. They all kind of, they connect like this. It's all mashed together. You can scale a business like this, even with a collapsed core, because even though they're focused like this, if it's all layer 3 switches, this is very scalable. You can scale it to thousands of users. In Cisco, in San Jose, for instance, they have several buildings, and every single building inside has a model that looks like this right here. But here are a few pictures I've got for you of what those racks of equipment can look like. Now, I've heard of Cisco Labs, and I've never been there, but And when I heard of them, I always thought that they would run a lot of simulations, like emulating software like GNS3 or IOX on Unix or Linux. But they have the real deal. Of course, because it's Cisco Lab and they do have access to the equipment and the money for this. So these pics are from Cisco Lab in North Carolina. And I've heard that you can actually hear the fans outside the glass. This is absolutely huge. The CRS Equipment Lab. Each one of these racks is actually hundreds of thousands of dollars. And this is one row. Here's multiple rows. Can you imagine being here? I mean, look at how huge this is. Just rows and rows of lab stuff. This is just for testing. It's just stupendously filled. And this is just to give you an idea of what you could run into in an enterprise situation. Companies like Amazon, Google, Facebook, and others have a core layer. Now this, what you're looking at, is a core layer. The sheer density of equipment that you could end up dealing with. Now I've dealt with this myself. I've worked for a co-location site. They took care of multiple enterprises, and they had a situation much like this. You would walk into this server room, the core, and you didn't know where to begin. Very often you'd have a call out for a specific server. You didn't know where to find it. You could end up dealing with the Microsofts, the Intel, American Express, Bank of America, Lufthansa Airlines, eBay's, or any other company like this in this world. This is enterprise business. Or many co-location sites are truly like this as well. Any business that can afford a dedicated backbone of technology. But when you're referring to the enterprise composite model, Cisco just wants you to design your network in blocks. Each one of these squares is a block. Now, you might ask me next, how do you define a block, Steve? Is it when I reach a certain number of devices? And I'll tell you, it's up to you to define it. It's all based on your network priorities, and what you have. A block could be a building, 50 people or 500 people. It could be a block as a floor inside a building. A block could be departments broken out of the building, and maybe departments are mixed within rooms, hence needing the services of flexible switches and VLANs. That's where this micro-segmentation comes in. You might have multiple departments represented within one room, and all these people are in different VLANs. But Cisco recommends just separate your servers into separate blocks, and a block could have a bunch of VLANs again. Let me ask you, why do you think they recommend that? Well, there's a couple of reasons that it should be done that way. Number one reason is security. Security is a major factor. Each one of these blocks represents a boundary to where you're not worried about general unpredictable traffic crossing that boundary. The servers are isolated, for instance. What if a person walks in with a laptop that has a virus? What if they invite their son or daughter in with them in the afternoon and they go to play a game and somebody plugs into your network? With segmentation, the block that the servers are on is invisible to the network that the infected user laptop is on. Another reason is traffic surges. What if a network card were to go bad out in the user area? You don't need a berserk end user's PC sending out crazy packets for any reason, flooding your server farm with junk, either from virus infection or from a bad NIC, let alone what a hacker with physical access to your LAN could do. It's security. You could segment things based on network performance. You could segment based on quality of service, or a block represents a whole different treatment of traffic, period, within a block. You don't have to do that, but you can apply the same treatment everywhere in one block. But this represents the ability to do that type of thing. You'll have a server block, a client block, an executive block, or a visitor's block. Here in this diagram, take a look up top right. This is your exit block, where you can access ISP 1 and 2. You could have a DMZ, a demilitarized zone block, and then expand your DMZ block if needed. all these different things that you could do with this technology if it is designed correctly.